So photoelectric effect. Okay. Perfect. So now, when you consider photoelectric effect, what comes into your mind?
Light.
Light. So the definition of photoelectric effect is that you are going to define it as the emission. So this is the emission. This is the emission of an electron the emission of an electron from a metal surface. So what usually happens here is that if you have a metal like this, based on metallic bonding, you know that this metal is made up of a lot of electrons. So when light strikes this metal like this, it strikes this metal, we expect an electron to be emitted from the metal surface. Okay. So we call this light striking the metal there as the incident light. Okay. This is the incident light. Okay. Now, the principle behind this electron for it to be emitted, what usually happens is that this light striking the metal here should have higher energy than the energy holding the electron here. So within the metal, there is what we call threshold energy. We have what we call threshold energy. Okay, so this threshold energy is the minimum energy required for an electron to be emitted from the metal surface. So this energy striking the metal here should be greater than the energy, which is the threshold energy holding this electron in a metal surface for this electron to be emitted. So you are going to say, for emission to be possible, okay, the incident energy, which we can call as E1, incident energy, okay, the incident energy must be greater than the threshold energy. Okay. Now, what is threshold energy? So threshold energy is the minimum energy required for an electron an electron to be emitted from the metal surface. Is that okay?
Mm.
So we should always remember that for emission to be possible, the threshold energy, or rather incident energy, must be greater than the threshold energy. But if you find that the threshold, the incident energy is less than the threshold energy, then emission will not be possible.
Possible.
Yeah. Now, we should again remember that when this electron is emitted like that, it obtain what we call kinetic energy. Because it is moving from this metal surface, it's being emitted like that. So it tends to obtain kinetic energy. Now, how do we calculate kinetic energy? So we are going to have kinetic energy of an electron So kinetic energy is equal to the general formula that we have, that we know from high school and just even in physics, is that kinetic energy is equal to mv squared. Remember this formula? So this now, for incident, for an electron, this is equal to incident energy, that energy striking the metal surface, minus the threshold energy. So we can give it the symbol as phi, like that. So we know the formula for energy. Energy is equal to what? HV, right?
Yeah.
Minus, so for phi, we can call it as HV or initial, to indicate that we are talking about the initial energy. Okay, so further, we know what this means, right? Frequency has its own substitution. So we know to say H, where there's frequency, we can put C over the wavelength minus. So in many cases, you are going to be given the threshold energy. So you can just say phi. So this is basically the formula now for kinetic energy. So it's incident energy that you have minus the threshold energy. That's how you can calculate the kinetic energy of an electron. In a case where you are working with the light at a certain wavelength. But if you have been given the speed, we've been told that the speed is, let's say, 25 meters per second, and we know to say that the mass of an electron is, do you know the mass of an electron? What is the mass of an electron?
Right.
Someone has forgotten. What's the mass of an electron? It's 9.11 times 10 to the power negative 34 kg. Okay, so you just have to substitute it where there's m there, and if you have the mass or the velocity or the speed, you need to substitute it there and calculate the energy. But if you have the wavelength you've been told that the light striking the metal has the wavelength of this, you can use this formula. And if you have been given the threshold energy, then you can just substitute and calculate your kinetic energy. So the kinetic energy, the units is joules again. Okay?
Yes.
Perfect. You have any question?
Not right now.
Not right now. Okay, so let's proceed. So according to Einstein, Einstein predicted that he said energy is equal to mc squared. So we can use this formula to find the mass of an electron or to find the wavelength of anything given. So how do we do that? We need to develop or to drive the formula for the wavelength. So the question is, how can we get the wavelength of an electron if you have this formula? The first thing first, we know to say this is energy. And what's the formula for energy?
HV.
HV, perfect. HV, so HV is equal to mc squared. Again, where there is V, we know what frequency stands for. So H, where there is V, we will substitute it with C over wavelength is equal to mc squared. But observe that we have the C speed on the right-hand side as well as the speed on the left-hand side. So we can cancel one. So if we cancel one, we just remain with one C there. So we are going to have the formula of H over wavelength is equal to mc. So our interest is to come up with a formula for wavelength. So we can say over 1 cross multiply. When that happens, we're going to have wavelength mc is equal to h divided by mc divided by mc. So that cancels. The wavelength is equal to h over mc, where this is the mass. The mass must be in kg, and this is the speed. So this speed or velocity must be in meters per second. And this is what? The Planck's constant, which is 6.626 times 10 to the power negative 34 joule second. Is that okay? All right. So let's look at an example. Let's look at the question. So we can have an example. So the question is calculate the Broglie wavelength which is associated with a ball with A ball weighing weigh 380 grams thrown at a speed
So that's the what?
the Broglia. I don't know the pronunciation. It's DBRGLIE.
Okay.
How can you pronounce it yourself?
The Broglie. I don't know.
The same one, the same thing you have done. The same pronunciation
Okay.
is still fine.
Okay.
Yeah.
That's 380 grams.
380 grams.
Okay.
Thrown. Thrown. What's happening? Okay, so thrown at a speed or at a velocity. Okay, so we've been told that at a velocity of 100 kilometers per hour. So we have everything, not so. So the data we have, the mass is equal to 380 grams. So when you convert this to kg, it will be what?
Just a minute.
So you just have to divide by 1,000, not so. Okay.
0.38.
0.380 kg. Then we have the velocity. The velocity is 100 kilometer per hour. This must be in meters per second. So what are we going to do?
3 multiply it.
We need to convert that to meters per second. So how is it going to be? So if the conversion 100 kilometer over hour times 1,000 meters is equal to 1 kilometer times 1 hour is equal to 3600 seconds. So hour goes, kilo goes. So when you do that, what are you getting?
Just a minute. Um, 27.7.
27.
0.7777.
Okay, so we can meters per second. So we can just say 27.8. Alternatively, if you are in a hurry to convert kilometer per hour, you simply have to divide that by, if you are in a hurry, you can just divide this by that, by 3.6.
Okay.
If it is like in kilometer per hour, every time anything in kilometer per hour, if you divide by 3.6, you get the conversion just right away.
Okay. 100.
The same, you have 100 divided by 3.6, it will give you the meter.
Yeah.
So whatever you
Yes.
it will be in meters per second. So now we have the velocity in meters per second, 27.80 meters per second. Therefore, the wavelength is equal to h over mc. So h is 6.626 times 10 to the power negative 34 joule second over the mass is 0.38 kg times the speed is 27.80 meters per second. When you do that, what are you getting?
Just a minute. I'm getting 6.272.
You are getting what?
I'm getting 6.272.
Okay, sorry. So you are getting 6.2.
6.27.
Okay, so getting 6.627. 6.27.
2. I continue the whole thing.
No, you can give it in standard form times 10 to the power.
Times 10 to the power negative 35.
So this one is in meters.
Okay.
That okay?
Mm-hmm.
So that's how you can attempt questions of that nature. All right, so I'll send you the other questions related to what we've covered on photoelectric effect as well as on this one. So now the next topic we are going to start, the next part will be quantum numbers now.
Okay.
So start on quantum numbers so that at least we will not have any challenges. All right, we can end here.
Okay.
Okay.